And it's very, very clear that we will expect many more frameworks to be developed and many more applications in the future for the benefit of humankind. So, thank you.
Thank you, Olof. Let's see now. Do we have Professor Kitagawa on the phone?
Yes.
Good evening, Professor Kitagawa. Again, our warmest congratulations to the Nobel Prize in Chemistry.
Good evening. Thank you very much. I'm deeply honored and delighted that my long-standing research has been recognized. Thank you very much.
I know that you are very busy tonight, but do you have a few minutes to take some questions from the press here, the media? We have this press conference right now where we have both national and international press. So can you take some?
Okay. Yes.
SVT, Swedish television.
Good morning, Professor Kitagawa.
Okay.
My name is
Good morning.
My name is Susan Ritson, and I work for Sveriges Television, Swedish public service television. I want to congratulate you on your achievements.
Thank you very much.
I was wondering, science aside, what were your thoughts when you received the news just a short while ago?
Yeah, this is the I heard this introduction of our works, and this is very new materials, so it's a long time to realize in our society that this is real, the porous materials. That is very, very big effort to do it. But meantime, I really enjoy the chemistry of these materials. So this is my feeling, and so once again, I'm deeply honored and delighted, and my long-standing research has been recognized. And I think the Omar Yagi also think about this.
I know Professor Olof Ramström mentioned that your discoveries gives us hope. Do you agree? And what are your hopes for the future with the MOFs?
Yes, I'm very much interested in transform this material to the society, of course, but this material is also a kind of surprising properties. So this is my fun to discover new properties depending on the softness and also the several and the new characters of and the properties of these framework materials.
Okay, next question.
Omedetou gozaimasu. Omedetou gozaimasu.
Arigatou gozaimasu.
I'm Anneli Megner-Arn, TV4. I'm wondering, would this technique make it cost efficient to suck out carbon dioxide from the air to help fight climate change?
Yes. Yeah. So the properties of these materials is the sort of the well-defined porous structure. So that means the surface of the pore can strong interaction with the CO2, but this interaction is in a scientific word that is the physisorption. So the interaction energy is not so strong. So that means easy to capturing these materials, but easy to release this material. So energetics is quite the important for this technology. So this material can realize it. I think it.
Okay.
Please.
Hello, Mr. Kitagawa.
Yes.
It's known that MOFs shows great potential in gas storage and catalysis, but mass production remains costly. What technological breakthroughs in the next 5 years could truly advance their commercialization?
Yeah, we are thinking about with my startups, And in the world, for instance, in the energy materials and the methane, in that case, for instance, well-developed countries, still difficult to have pipelines all over the country. So this means we need to still have the cylinder or something for the store this methane materials, but it's very heavy because the high pressure cylinder we use. This is 100 years tradition. So by using these materials, we can make this cylinder is lighter and lighter and easy to deliver to any places. So this is a reality in the next 5 years, I think.
We have a Polish TV here.
Hi.
Hello, Professor. This is Bogumil Radziejewski from the Polish television. Congratulations. I wanted to ask you, because what's so amazing about the metal organic frameworks is the wide variety of applications they have already found. I'm wondering, in what field do you find most important or possibly most promising for the future in terms of practical applications of MOFs?
Yeah, my dream also, this is not realized. My dream is to just handle the air, because air contains CO2, oxygen, and the carbon elements, oxygen elements, nitrogen elements. That means, for instance, if you think about your body, proteins contain carbon, nitrogen, oxygen. And also fuel contains carbon, hydrogen, and something. So air contains most of the elements for our important materials. So my dream is to capture air and separate air to, for instance, in the CO2 or oxygen or water or something, and convert this to the useful materials using the renewable energy. Okay, so even if we obtain the fuel from the air, so fuel is combusted into the air, but we can still the reuse of this air. So that cycle is quite important for our society and also our planet. So this is my dream, and also we have to realize it using this kind of porous materials. This is my answer.
We have a question here, please.
Hi, Professor Kitagawa. This is Yue from Chinese Media, The Intellectual. My question is, how persistent is materials created using this framework? Will it dissolve soon, or could it last for centuries? And what is the environmental implication of that? Thank you.
Yeah, and first of all, I have to say I'm very enjoying, even I have a very difficult situation. So creating new materials is very important.
We might have lost him there. See if we can make a new try. We give it a few more seconds a chance here.
Hello?
Hello, yeah. Now you're back here. Maybe we should take a new question. That's probably easiest. Over there.
Okay, so...
Hello. Do you hear me?
How long I have to stay here? How long? Because I have to go out for the meeting.
Okay.
So
I have
how
one
long?
last question.
5 minutes? Okay, sure.
Okay, I'm from the Swedish media magazine called Forskningen Framsteg. I would just like to know, what was your, did you anywhere during all these years of research hesitate or doubt that you would manage to create these frameworks? And what was the biggest challenge, the threshold that you had to manage? Can you say something about that?
Yeah. So the advent of this material, we have already current material. We have activated carbons, zeolites, and so on and so forth. So we have to show this material is quite stable, even without gas molecules. So this is a very tough time. So but I was so optimistic because the create of new material is very, very much fun. It's very challenging. So anytime I told to the students in the challenge is very important in the chemistry and science. So that's a point in I recall I look back this time.
Okay, we take one final question there, please.
Oh, final, okay.
My name is Riko Takahashi and Kyoto News Japan. I say even in Japanese, おめでとうございます. And then if you said you are short of time, so I just do simple questions. Where were you when you got, I have two questions. Where were you when you got a phone call from the Nobel Committee? And
first answer.
And,
very surprising.
I continue.
Very surprising.
Oh,
very surprising and
now?
Also very pleased. Yeah, very happy. Because this is a long-standing chemistry. So this is recognized. This is my I'm pleased to know that. And maybe we can share this feeling with the Omar and Richard.
Okay, Professor Kitagawa, I think that's the final question. Thank you for your important answers here, and we look forward to see you here in Stockholm in December.
Yes, I will. Thank you very much. Thank you.
Thank you. I can inform you that we were able today to reach all three laureates, so they have been informed. Now there is time to ask any further question there might be to the prize committee about the work or something else that is related to the Nobel Prize in Chemistry. Are there any further questions?